If you search for a home studio setup for beginners, you can end up with a shopping list long enough to fill the room before you record a single note. Let's reverse that. A studio is not a pile of gear. It is a signal path that lets an idea become a file you can judge and improve. The smallest useful path has 6 jobs. A computer runs the recording software. A digital audio workstation, or DAW, captures and arranges the performance. An audio interface moves sound between the analog world and the computer. A microphone or instrument creates the input. Headphones or monitors let you hear the result. Stands and cables keep every connection stable and repeatable. You may already own part of that path. An interface becomes valuable when you want XLR microphones, instruments, monitors, multiple inputs, or direct monitoring. Here is the rule for the whole video. Buy for the sessions you will actually run in the next year, not the imaginary studio you might build someday. By the end, you will know what each piece does, where it belongs, how to set it up, and which upgrade should come first. Start with the computer, because every other choice depends on it. There is no honest universal answer like, every beginner needs this exact processor and this much memory. DAW requirements change, operating systems change, and a songwriter recording 8 audio tracks has a different workload from a producer running large sample libraries and dozens of instruments. Choose a DAW, open its current requirements page, and verify operating system, processor support, memory, storage, and audio driver guidance. Think beyond the minimum, because audio files, sound libraries, and plugins consume storage, memory, and processing power. Build a representative session with several audio tracks, expected instruments, and effects. Record, save, reopen, and play the busiest section. If it is stable, keep using the computer. If it struggles, first freeze virtual instruments, increase the buffer while mixing, close background applications, and move large libraries to suitable fast storage. Upgrade the computer only when a repeatable workload proves it is the bottleneck. A newer machine cannot fix a noisy room, poor microphone technique, or an unfinished song. Next comes the DAW, the place where recording, editing, instruments, effects, and arrangement meet. Beginners often ask which DAW sounds best. For ordinary recording and mixing, workflow and support matter far more than internet mythology. The best first DAW is one that runs on your computer, recognizes your interface, includes the tools you need, and makes you want to finish projects. Try an included or trial version. Confirm that you can choose an input, arm and record a track, trim a clip, add a fade and effect, automate a level, and export a stereo file. That reveals more than a feature chart. Then commit for a while. Finish 3 songs before switching because a different interface looks exciting. Keyboard shortcuts, routing, and file organization become creative speed only through repetition. Create one template with named inputs, a vocal track, an instrument track, a reference track, and a clean master bus. Save every song in its own folder. A simple DAW you understand is more capable than a complex one you keep restarting. The audio interface is the studio's border crossing. It converts microphone and instrument signals into digital audio, then converts the DAW's output back to analog for headphones and speakers. Choose it by counting real inputs and outputs, not by counting features you may never use. One microphone preamp may work for one source at a time. Vocal and guitar together, 2 people, or a stereo keyboard need 2 inputs. A drum kit or live group needs more. Look for a proper headphone connection and 2-line outputs if monitors are planned. Match inputs to sources. Microphones normally use XLR into a preamp, guitar and bass pickups usually need an instrument input, and keyboards may use line level. Condenser microphones commonly need phantom power. Follow both hardware manuals. Finally, verify driver support for your operating system and connect the interface directly when possible. On Windows, the manufacturer's ASIO driver is usually the intended low latency path. A direct monitoring feature is especially valuable because it can send your live input to the headphones before the computer returns it, reducing the distracting delay you may hear while performing. Now decide how you will listen. Headphones and studio monitors solve different problems. Wired closed-back headphones are often the smartest first purchase for recording because they reduce sound leaking into the microphone, work at night, and remove the room from the immediate playback path. Avoid Bluetooth while tracking. Wireless delay can make a performance feel late, even when your timing is fine. Learn headphones with good reference tracks, use moderate levels, and check important decisions on another familiar system. Monitors become valuable when you can position them consistently. Connect them to the interface's line outputs, not a random laptop jack. Lower interface output, connect with speakers off, then power up and raise level gradually. If the room is highly reflective, asymmetrical, or shared with neighbors, expensive monitors may reveal more room problems than mix detail. In that case, start with reliable wired headphones and improve the room before buying bigger speakers. Monitoring is a system. Transducers, placement, room, level, and your own listening experience all work together. Microphone choice becomes easier when you stop asking which mic is professional and start asking what you are recording, where you are recording it, and how close the source can be. A dynamic microphone uses a diaphragm attached to a voice coil moving in a magnetic field. This construction is rugged and can handle high sound levels. Many dynamics have lower sensitivity than typical studio condensers, which often encourages close placement. That can be helpful in a noisy or reflective bedroom because the wanted voice is strong relative to the room. A condenser uses a charged diaphragm and backplate, plus active electronics, usually powered by a battery or phantom power. Its sensitivity and detail can suit vocals and acoustic instruments in controlled spaces, but also reveal fans, traffic, reflections, and chair squeaks. Polar pattern matters too. A cardioid microphone is most sensitive toward the front, but front depends on the model. Some are side address and some are end address, so check the diagram instead of guessing. Start close enough for a healthy signal, use a pop filter for vocals, and aim the microphone's least sensitive area toward the main unwanted noise when practical. Choose the microphone that makes the source easiest to capture in your actual room. The least glamorous equipment often decides whether a session works. A stable stand preserves microphone position, a boom reaches over a desk or instrument, a pop filter controls vocal airbursts, and a compatible shock mount can reduce vibration. Each removes a preventable problem. For a typical XLR microphone, use a balanced XLR cable of sensible length. For powered monitors, use the balanced connection supported by both the interface and speaker when available, commonly XLR or quarter-inch TRS. Guitar cables are generally unbalanced instrument cables. They are not the same thing as a balanced TRS line cable, even when both plugs look similar from a distance. Label both cable ends, leave strain relief, and prevent performers from stepping across the signal path. Keep one known good spare for the connection that could stop a session. Before connecting speakers or enabling phantom power, lower listening levels and follow the hardware manuals. Never force a connector. The goal is not merely to make sound once, it is to build a physical setup you can reset quickly, troubleshoot logically, and trust when inspiration arrives. Room placement is the cheapest major upgrade because moving a desk costs less than replacing the gear on it. If you have a choice, begin in a rectangular room and build a symmetrical listening position. Center the desk along the room's left to right axis, so the nearest sidewalls behave as similarly as possible. For stereo monitors, place the left speaker, right speaker, and listening position at roughly equal distances. That creates an equilateral triangle with about a 60-degree angle between the speakers from your seat. Aim each monitor toward the listening position according to its manual and keep tweeters near ear height. Measure instead of eyeballing. A tape measure and a piece of string are enough. Do not blindly pull every monitor far from the front wall. Design and manufacturer guidance matter. Genelec, for example, advises close-to-wall placement in many no-subwoofer situations, typically with the monitor front less than 60 centimeters from the wall. Other models differ. Start with the manual, then test. Play familiar mono and stereo references. If the center image pulls sideways, recheck symmetry, level, angle, and distance. Small placement changes can alter bass dramatically. Mark the final positions so the setup survives cleaning, collaboration, and accidental desk movement. Acoustic treatment and soundproofing are not synonyms. Treatment changes what sound does inside the room. Sound isolation reduces how much sound crosses the room boundary and usually requires construction, mass, airtightness, decoupling, and attention to doors, windows, ventilation, floors, and ceilings. Foam tiles cannot make a loud room silent next door. Start treatment with diagnosis. Clap for metallic flutter, play a low-frequency sweep to find major bass changes, and record a voice at the plan position to hear boxiness or hard reflections. Prioritize broadband absorption at early reflection points beside and above the listening position, with thicker absorption where low-frequency buildup is strongest. Thin foam mainly affects shorter wavelengths. It is not a complete bass solution. For vocal recording, moving blankets or purpose-built panels placed with safe stands can create a more controlled zone without permanently covering the room. Keep absorbent material behind and around the singer, where it interrupts strong reflection paths, while preserving safe airflow and access. Treat, listen, move, and measure again. The goal is not a room that looks like a studio. It is a room where recordings are repeatable and monitoring decisions translate outside it. Gain staging means giving the signal enough level to stay clearly above noise without clipping the next stage. Begin with the microphone positioned and the performer delivering the loudest realistic section. Set the microphone or instrument input correctly, arm the track, and raise interface gain while watching the door meter. Digital clipping is not a badge of energy. If the interface's clip indicator lights or the door reaches 0 decibels full scale, lower the input gain. Focusrite gives roughly -12 to -18 dB on a door meter as a practical recording range, while noting that advice varies. Treat that as useful headroom, not a magic target every syllable must hit. Headphone volume does not set recording level. Make the monitor mix comfortable after input gain is safe. If software monitoring feels delayed, lower the buffer only while the computer stays reliable or use direct monitoring. That path may bypass door plugins, so the performer may hear a dry signal. Record a loud test and a quiet test. Listen for clipping, hiss, electrical hum, room noise, and headphone bleed. Fix the cause before recording the whole song. Good gain staging is intentionally boring, clean input, comfortable monitoring, generous headroom, and no surprises later. Make the first session a system test. Create audio, export, and note folders. Set the interface as input and output, activate needed inputs, choose the sample rate, and confirm the recording location. Then trace one signal from beginning to end. Microphone to XLR cable, cable to the correct interface input, interface to the computer. Door input to an armed monotrack, track and master bus to the interface outputs. Headphones or monitors at the end. Name the track before recording so the files remain identifiable. Make a 30-second take containing normal performance, the loudest passage, and a few seconds of room tone. Stop and play it back with the track disarmed. If you hear an echo while tracking, you may be monitoring the same input through both the interface and door. Choose one path. If you hear nothing, move through the chain one stage at a time rather than changing 5 settings at once. Export a WAV and a listening copy. Play them on a phone, another pair of headphones, and a familiar speaker. This proves that recording, saving, reopening, playback, and export all work. You now have the real home studio checklist: a compatible computer, one door you know, an interface sized for your sessions, a microphone suited to the source and room, wired monitoring, dependable stands and cables, thoughtful placement, selective treatment, and clean gain staging. When it is time to upgrade, follow the weakest link. If mixes change wildly on every speaker, improve monitoring placement, treatment, and reference habits. If recordings contain too much room, change position, technique, and treatment before changing the microphone. If you constantly unplug sources or cannot record collaborators, add the inputs you genuinely need. If sessions overload after workflow optimizations, then computer capacity may be the verified bottleneck. Do not mistake novelty for progress. A microphone upgrade will not improve a bad performance. New monitors will not correct an asymmetrical desk. More plugins will not organize unfinished sessions. Spend first where a repeatable problem has a clear cause. Build the minimum studio, finish a song, write down what slowed you down, and solve that one thing. Then finish another song. The studio becomes professional through repeatability, the same placement, the same signal path, reliable files, and decisions that translate. You do not need everything. You need every essential piece to do its job, and you need enough experience to know what the next piece should solve,